Hi everyone, this is Elixir's most published author, Bruce Tate. In this video, we're going to talk about OTP, the soul of Elixir. This video is an introduction to core concepts. If you want to dive deeper, I invite you to come to Groxio. There you will find video courses and professional training opportunities to get that job or secure the promotion that you've been looking for. Let's go. Hey everybody, this is Bruce and the dog on the floor, and today we're going to talk about OTP. Specifically, we're going to talk about the concept of a behavior. So what is OTP? OTP is a library for managing processes. It has a common API for dealing with message passing and lifecycles, and that is it. And so I want to focus on this little piece that says it's a common API. And what that means is we're going to be talking about the concept of a behavior. Think about a behavior as nothing more than a plugin for Elixir. So how do I specify the API? Well, we'll do that next. For this exercise, we're going to spend most of the time in our console and in IEX and the editor. So let's go ahead and get that much started. So we're going to build an application that does nothing more than work in a loop. And then we're going to use behaviors to separate those two concepts, the looping and the working. So let's start that much now. So I'm going to say mix new loopy. That's going to build the application. So I'm going to cd to loopy. And then we're going to go ahead and start the editor. Okay, so here's the editor, and I'm going to basically reveal the code structure here. This is the file that we're going to be working in, and I'm going to delete the module documentation because it's not going to reflect the work that we're doing for very long. So I'm going to basically start with the work that we're going to do. So I'm going to say work, do, and let's see, what should this do? So let's say def work, or so this is the work. Okay, so now we're going to do a sleep. Let's say just for 100 milliseconds, a tenth of a second or so, just to slow things down a little bit. And then I'll say io.puts. And then what do we print? What's a repetitive song? Let's say oh no, we gotta go. Okay, so what we have is Louie Louie, oh no, we gotta go. And then it will do this over and over for the rest of time. Okay, so now that we have the work, now let's make it loop. Def loop. And all we're going to do here is we're going to work. And then we're going to loop. And you might be worried about performance if you come from an object-oriented language. This is really okay, because we're going to optimize, the compiler is going to optimize for us, as most functional languages do, with a feature called tail recursion optimization. And in case you're imagining starting this from IEX and kind of going crazy, well, yes, we would, because we get into the loop and there will be no way to get back out. So let's do this in another process. So I'm going to say process, or actually let's say def run, do, and then I'm going to say spawn. And then I want to start this function, which has 0 arguments. So to call this out as a function that I'm passing, I'm saying don't execute it yet. I want to provide this function to spawn and then let spawn execute it, presumably after it starts a process. So it's going to be loop, and there are 0 arguments. I'll put the postfix on there of /0. And now we ought to be able to make this much run. And so we'll go ahead and try that next. Okay, so now I can start up the application. Okay, so now all I need to do is run that loop program. So let's think about this a little bit. So that spawn is going to generate a process ID. And so all I really need to do is go ahead and let this fly. And when it's time to kill it, I can just kill it with one of the process commands. So let's do that much work now. I'm going to basically say loopy dot, there are the choices. I'm going to do this one. I'm going to run. Okay. So this is going to keep running forever, right? And so I could say process dot kill or exit. Oh, and we didn't grab the process ID, but we can go back in time and grab that with a V. And then, so I can provide a line number as well. So the first line of IEX. Okay, so now I've killed that process. So this does basically everything that we want it to do. This loops, well, it does most of what we want to do. The problem is that we have this great looper feature, but we have no way of providing work for it to do. So what we would like to do is pass in a module that has an explicit API, one that actually executes work, and we could send that module into our looper, and that's what we're going to do next. Okay, so the problem here is that this work is tightly coupled to the actual thing doing the looping. So let's decouple a little bit the idea of the work and the idea of the looping. So this module is going to do the looping and the other module is going to do the work. So one of the ways to do that is to allow the user to pass in a function. But let's say that we eventually are going to expand this to include the amount of time to sleep and also the particular work that we want to do, right? So this is going to be spacing, and sometimes we might want to have no spacing at all, and sometimes we might want to actually have a lot of spacing, and in any case, we want this work to be pluggable. So let's think about how we would go about doing that. So if we build a second process, so let's go ahead and build a module. Let's call this loopy. We have a folder, and then we're going to build a module inside called song. And this song module is def module, we want loopy.song. And then that's going to do two things, right? It's going to have work. And then here we're going to do the work. And then it's going to have wait. And here we're going to do the wait, right? So I'm going to grab, for the work, I'm going to grab this code right here. And for the wait, I'm going to grab this code right here. This doesn't have to do a sleep. It could do anything else that we want it to do in order to wait. It might wait on something else, on some other service. There might be some type of synchronization. I don't know. I really don't care. But for the purposes of this demo, what we're trying to show is that I have really more than a function that I want to pass around. And so how do I make this available? So in this case, I could have 1 degree of separation by taking some type of a module in here and say module dot wait, and then have module dot work, right? So in this case, I'm waiting and working, But now this doesn't work quite right. So probably what I want to do is pass the module that I take as an argument through like this. So now I take the module, I pipe it through to work, and I pipe it through to loop, but I'm going to have to call run with the module, and I'm going to have to use that module right here. So function, and then I'm going to say loop over the module like that. Okay, so let's see if this works like the other one did. So I'm going to bring this up. I'm going to recompile. And so this time I'm going to say PID is equal to, and by the way, sorry at home for the earworm that I planted with this song. You know, this one can stay with you for days, and my profuse apologies here. At least I didn't do the baby shark one. Okay, so let's say loopy dot, and then we want to run, right? But we need to provide the module, which is loopy, like that. Okay, so what happened was we got an exception. OK wait is undefined. The module OK is not available. So, oh, I see what happened. Can you tell what happened here? We have a pipe that's sending an OK through where we probably don't want it. So let's look at the line of code that's actually breaking the loopy.work right here. And let's see if we can't fix that problem. So let's go ahead and pick up our code. Okay, and so we have the module. And then we say go ahead and do some work. And then I can return the module here, because this is going to return OK or something like that. And let's see if that makes this application work. So I'm going to go back to back here, recompile. Okay, and there we go. We're off to the races again. And now I can process.kill. And by the way, this is still running. So, yep, it's still running. So I can say process.kill. And then I want to provide the PID and the reason. Okay. Did I not grab the PID? I guess I didn't grab the PID correctly. So that would have gone on forever, so I needed to kill it. So right now, we've actually taken one step towards our goal. We've done a little bit of separation between the concept of the working and the concept of the looping. We need to do one more thing though. Right now, there's no guarantee that this module has the right interface, that it implements the two functions that we need with the same type signature that we need. And so the way to do that, what we've done here is we built a small plugin without guarantees. And the plugin that we used was the module, because we can apply any module that we want to this particular problem, as long as it implements work and wait. And what we're going to do next is enforce a contract for work and wait. And that's precisely what a behavior does. So next, let's build the behavior. All right, so let's set about the work on building our behavior, but we're going to need a little bit of information to do that. So let's go ahead and go back here. I'm going to say IX mix. And then we're just going to search around in the help system and see if we can find what we're looking for. So I'm going to say HB behavior. I'm not getting anything. So I'm going to look for uppercase version behavior. Okay, so I'm getting something, but look, it's deprecated. So that's not going to tell me what I need, but it is giving me a hint. It says use the callback, and I assume that callback is just a function, or use the macro callback, and this is just a callback that's a macro. Oh, that's a macro. And remember, a macro is just a something that looks like a function that writes code and drops it in place. And it uses those attributes instead. So check out that on the module instead. So let's say H module. Okay. So here we are in the module. Okay, there's callbacks. Okay, here we go. So a callback provides a specification for a behavior callback. So that's what we want to do. So in this case, we're going to use this callback with the type spec. Let's see if there's an example down here. Use callback. Okay, here's a callback. Yeah, so this is great. Like a default port and integer. This is exactly what we want to be able to do, right? In our other application, we ought to be able to specify the behavior like this, right? So this is the default port and this is parse. So this is the cocktail that we're looking for. We're going to do this first. So let's go back to the code editor here. And in the song, that's going to be the consumer. This is where we actually need to specify the callbacks, right? So this is going to be loop. What's the type going to be there? Let's say that is an any. Let's see what this gives me for my type spec. So this is wait and okay. This is work and okay. So let's go ahead and make that our type spec. So I'm going to grab this and I'm going to drop it in place. All a type spec is a contract. It's a definition of the types that make up the arguments and the return for a function. So if I can paste the callback in here, we don't need that spec. We're specifying a callback. And so this is going to be the work function with no arguments, and it's going to return okay like that. And the other one is going to be similar, right? So this is the wait function with no arguments, and it's going to take okay. All right, so that much is done. And let's make sure that this compiles okay. So we're going to recompile. Okay, so that looks okay. And now we can go ahead and consume the behavior. So let's look at a behavior like this. Notice the British spelling. Yes, there is a U in there. Thanks, Joe Armstrong. So there was a beautiful tweet by Jose Balim, the creator of Elixir, that I read a couple of days ago. And he said, whenever I type behavior, I think about Joe. Indeed, Jose, indeed. Okay, so this is a module that's specifying a couple of callbacks. This is the behavior itself. And it's a behavior by virtue of the fact that we do specify callbacks that we're going to use elsewhere. And here, all we do is specify the module that has the callbacks. So let's go ahead and do that. So I'm going to cut back over to the code editor. And we're going to go to the song. And we're going to use the behavior loopy. Great. So I'm doing that much. And notice there's nothing inside loopy itself. There's nothing in here that refers to the modules that are underneath, except in the sense that I'm accepting a generic module that does certain types of things. And so one of the things that I want to show you is that this, as long as we declare that these participate in the behavior, the way to do that is impl true, right? All that impl true says is that these are part of the contract and the behavior that I've specified. So if that is true, then I'll get a little bit more compiler protection. So for example, I can recompile this and everything's working fine. But if I misspell one of these, like W-I-A-T, I'm going to save that much. And then I'm going to recompile. And I get a warning. So Elixir is yelling at me because I have an impl true on something, but it's not part of the behavior. So then that's going to prompt me to look more closely, right? So that all we have done is specify the nature of the contract between the song and the loopy module, right? But I can do a little bit better because I know a little bit about the behavior right here. I know about the module that implements the behavior, and I can use the feature in the behavior module itself that actually starts the process, that actually kicks it off, right? So this is what that looks like. So I could say def go. And notice that this isn't a callback, right? Because Loopy is not calling back into my code, but this is actually participating in the spirit of the interface a little bit better. My consumers don't have to know that I'm using Loopy under the hood. So I can do something like this. I could say loopy.run. And what module is it? Well, it's this one. Like that, right? So now I can go and I can build, I can call loopy.song.go. So now the end user, that's me, I don't have to know about the underlying loopy anymore. And that's going to go ahead and work. And I can actually build another implementation of the behavior. So let's do something like, say, I don't know, how about back seat, right? And so in this back seat, let's grab this implementation because it does most of what we want to do. And I'm going to paste this in. So go is going to be exactly the same. Work is going to look something like this, though let's be a little bit more interesting here. And the wait is going to look something like this. Let's do something like this instead. Random.uniform 5,000. Because we're after annoying with this particular interface. Let's say 5,000. Pipe that to Erlang's random.uniform and pipe that to process.sleep, right? Because, you know, when your kids are in the backseat on a long trip, the complaints can come on a regular basis and that could lull you to sleep, kind of like waves in an ocean. But when that time period is random, it's much more annoying. So that's the spirit that we're going for. Okay, so, and what are we going to have the user say? So let's say, I don't know, Al, quit it. The ubiquitous, are we there yet? And since I'm from the Southeast, let's go to Rock City, because there are signs to see Rock City thousands and thousands of miles from here. so the kids are always asking to see it. And how about I'm hungry? right? Okay, so all I've done is said, what am I going to inspect, right? So I'm going to pick a uniform. I'm going to pick a random one out of that, enum.random. And then I can pipe that much to io.puts. Right? Okay. Now I think that that's going to do the job for me. And do we want a new line on this? Probably do. So let's go ahead and drop a new line on there. And so now we ought to be able to say loopy.backSeat. And we ought to be able to make that go. So let's try out that much. So I'm going to say IXS mix. Random uniform is deprecated. Use the rand module instead. Okay. We'll go ahead and live with that though. And I'm going to say loopy.backSeat.go. And that's creating a process. And now I'm waiting. Ow, I'm hungry. I'm hungry. Now I'm waiting. Ow. Okay. So we have our nice and annoying backseat stream that's coming from it. And this is completely independent from the module that's doing the looping, except that they share a common interface. And that's exactly the way that GenServer is going to work with the rest of Erlang. It has a common interface that's specified in terms of a behavior, and that's an excellent thing. From Bruce and the dog on the floor, this is Groxio Learning.